Hello everyone, welcome to a new video. This is a topic which is a bit of electrochemistry and has its relation to CP. So I thought I should talk about it from a scientific understanding point of view. So, what is anode polarization? Anode polarization basically is a greater amount of oxidation reaction. When I say oxidation reaction means more material is getting dissolved from your pipeline. So that is anode depolarization. That is greater oxidation reaction. And this, what does this do? This results in lower concentration of oxidation products. Now, this may seem a bit confusing, so I'll just take the help of a diagram to explain it better. So, when the key features of this uh, anode depolarization are listed over here, I will try to use a physical diagram first to explain what it is. Now, when you have, suppose this is your medium, this is your pipeline. Now, when you have a pipeline exposed to the medium, it will start the anodic areas on the pipeline. I have to be very specific here. The anodic areas on that material will start to corrode, which means they will give off the M plus ions. These M plus ions will not remain floating around the pipeline. They will react with the Cl minus, NO4 minus or SO4 minus ions and form the reaction products. The reaction products will move away from the pipeline into the solution. So what does this what happens when this is occurring? The area around the pipeline now has more space for the corrosion to continue. So the oxidation reaction, the dissolution of the metal ions will continue. When this happens, what do we have? We have more corrosion. But we can't count it, so we need to quantify it in some way. That's why we will try to use the Tafel plot. So in this Tafel plot, you have potential on the y-axis and you have current density on the x-axis. Now let's take the cathodic areas on the pipeline and anodic areas on the pipeline. So the cathodic areas on the pipeline will have an open circuit potential of EOC. The anodic areas on the pipeline, let me just put it in a physically understandable form. This is the cathodic area, this is anodic area, anodic area, so on and so forth. So the cathodic areas will have a certain open circuit potential when they are outside the medium. When similarly, the anodic areas will have open circuit potential of EOA. When you put them together into a medium, they are now connected electrochemically. Electrically, they were already connected through the pipe, through the material. Electrochemically, they are now connected due to the medium. So their open circuit potential has now become polarized, which means it has now changed. Polarization basically is any kind of change. So their potential has now changed. How has it changed? Their potential will try to come close to one another's value. So if it has to come close to the anodic, obviously it has to undergo a reduction. If the anodic potential has to come close to the cathodic one, it has to undergo an increase. Now, because they are on the same material, we are not going to try and intersect them as in the original Tafel plots. I have another video explaining Tafel plots in the series for electrochemistry. I will try to link it somewhere on the video. So, as opposed to the actual Tafel plot, the EOC and EOA on a single material will not intersect. Okay, they will form some kind of a balance, and when this balance occurs, you have a corrosion current. So this is the polarized potential of cathode, which is the cathodic area. This is the polarized potential of the anode, which is the anodic area, and you have a resultant corrosion current. Now let's say this depolarization has occurred. How has it occurred? Maybe you have more of more of such chloride ions. Say you have more of oxygen or you have more H plus, so they will force the M plus to reduce to undergo oxidation because they're taking the M plus from the pipeline to react, cause the complete the oxidation reaction. Or maybe you have excess agitation. Agitation also means that you have more movement of the fluid. So if you have excess agitation, again you have more interaction of the cathodic of these negative ions, which will force more and more corrosion to occur. Okay, so why I'm saying force, because pipeline doesn't want to corrode by itself technically. If it encounters this such kind of negative ions, only then it will corrode. So if it has to corrode more and more, you have to have more of these negative ions interacting with the pipeline. So anything, any action that, or maybe higher temperature, that leads to more negative ions taking up positive ions, that will lead to corrosion. When this happens, that is what leads to the depolarization. What is this in terms of the coating? So when this depolarization occurs, this E is going to reduce further, and this EA is also going to reduce further. So what do we need if we need to reduce it? How does it get reduced? The EOA reduces down. Why I'm saying it reduces? When positive ions go into the medium, what is left on the pipeline? Electrons. So when there are more electrons, what will happen to the potential? It will become more negative. So this becomes the changed EOA. When this becomes the changed EOA, the slope also reduces. When this reduces, this is the resultant cathodic polarization reaction, which means how the cathodic areas are supporting the reactions. And this is the changed deep anodic polarization reaction, a polarization potential, which means it has become more negative. You can see that it may have, it has actually gone to this. So now this is the balance corrosion current. This is the changed corrosion current. And you can see that there is a change in the corrosion current in a increasing fashion. So it has changed from I core to I core dash, which is exactly what we saw in the physical picture, that when you have anode depolarization, you have an increased corrosion and you have the negative movement. Okay, a negative movement, more negative anode OCP, which is this, polarized anode potential, which is this, and the polarized cathode potential. So everything becomes more negative and the I core increases. So that is anode depolarization. I hope this clarifies the concept. If you have any questions, feel free to put them in the link. I'll try to answer them. So thank you, and see you in the next video.